Hello everyone, welcome and thank you for coming. We are going to be talking about front-end of data-driven applications. My name is Martin Artola. I work as a front-end architect at Swiss Life, a leading provider of financial solutions where I help teams to build and ship world-class applications. I like programming and actively contribute to the open source community. In such a context, I am a member of the Chili Green team. I push bits around our GraphQL platform, which has gained widespread adoption among many companies of any size, including some of the Fortune 500. Today, I am going to share with you some guidelines for building scalable applications right from the start. Before we dive into the details, let's clarify what we mean by scale. In simple terms, scalability refers to the capability of a system to handle growing workloads while keeping the performance, stability, and the user experience. But it goes beyond the simple throughput. We need to focus on the ability to adapt to the ever-evolving requirements of the different stakeholders. It is about making changes to the existing code base or introducing new features without additional cost. And this becomes critical as the system grows in complexity and the times and the size of the teams involved expands. We can overcome this challenge with the help of the right tools. Let's get started. Please raise your hands to answer these simple questions. Did you hear about GraphQL? Someone here? Oh, that sounds great. I am used to talking this .NET conference, and usually it's not really the best. Good. Good. Red guys, go out. Okay. GraphQL was created by Facebook in 2012 to power their mobile apps. Since 2015, the GraphQL specification was open sourced and now belongs to the GraphQL Foundation that is composed by several companies, and it is not anymore some Facebook stuff. Are you running GraphQL in production? Someone? We have some of them. Are you still experimenting with it? Are you maybe trying? Good. Or perhaps you are just thinking, oh, maybe no, we don't need it, we go with REST, we are used to do that. Okay, I will tell you, just hurry up. Look this thing. Gartner, a well-known research and advisory company, predicts in 2022, we will see GraphQL adoption continue to increase and accelerate. Oh shit, I'm reading the other one. In 2025, more than 50% of the enterprise will use GraphQL in production, up from 10% in 2021. That is, just in a couple of years, we will see a growth expansion of GraphQL. I was reading before the next one, that is about what Google says. Okay, Google states in 2022, we will see GraphQL adoption continue to increase and accelerate the use of BFF pattern. GraphQL allows companies to aggregate and deliver the exact data that the client needs without the need to package an API and an endpoint for each specific client. That is said by Google. But apart from Meta, GitHub, Twitter, Shopify, Starbucks, Microsoft, there are more than 20,000 organizations using GraphQL to power any kind of applications, web apps, mobile apps, and simple APIs. This is the case of Zalando, who identifies in their Tech Radar GraphQL as a language to adopt. But what is GraphQL and why we should use it? Okay. GraphQL is a query language for APIs and is a runtime for fulfilling these queries with your existing data. That means that we have two things, right? We have a way to query for data, to write our query language, but also on the other side is a server that will answer that exactly matching what we require. GraphQL flips the equation to the front end and redefines the way that we approach the data fetching. Now it is in the front end the capability to request the data from the front end and not define it like before from the backend side. Let's see some of the features. GraphQL allows clients to specify exactly what data they need, reducing overfetching or underfetching of data. Do you know what it is? Overfetching, underfetching. Okay, overfetching is when we receive more data than what we need. Okay, we are asking 2 or 3 fields, but we receive another 20. Underfetching is when we receive some data that is not enough, and then we are forced to make another call. Then we have a waterfall of calls. Typical REST APIs require loading resources from multiple endpoints. With GraphQL, we can get all the data that we need from a single endpoint and in a single request. GraphQL has a type system in its core principles, and we can make type-safe API calls by propagating the backend types to the frontend. GraphQL APIs can evolve by exposing new types and new fields without breaking the API, without the need of versioning. And GraphQL has a very widespread adoption, has a thriving community, and the developer productivity, the developer experience, is supported by tooling around the ecosystem. We will see this in a moment. Let's kick off the show. Selecting tools for the front-end development requires making wise choices. Here, I will talk about a very opinionated combination. Okay, this combination is about React, GraphQL, and Relay. I do understand that maybe you could have other requirements or other conditions in your company that make that decision is not so easy. But in the case that you have not that requirement, this is a good point to start. That said, GraphQL was created in tandem with the other products. Was created at the same time by Meta, was created GraphQL, React, and Relay to solve a problem. They were created to work together. There are synergies between them. Everything is much simpler when they work together. That doesn't mean that you cannot do GraphQL in different forms, of different ways, or with different other solutions. But this combination, GraphQL, React, and Relay, in my experience, works very well. Okay, then React doesn't need a presentation. With over 20 million weekly downloads, is a clear option. Maybe you think about the others, Svelte, Vue, Angular, name it. All of them together arrive at just 10 million downloads. That means that the React consumption is almost doubling all the others together, and the others are stale in this moment. I would like to see a different equation in the future, but I don't think that one of these will be which will make the breakthrough. I think that probably we will see some other evolving from here. Relay is a GraphQL client and serves as a bridge between GraphQL and the React components. It is composed from a Relay compiler, something that runs at build time and will validate and optimize our operations, and is also able to generate TypeScript or flow typings out of the box. And another part that is a Relay runtime that is optimized for performance. Relay runs out of the box in Next.js. You don't need to put any other extra package, you don't need plugins, you don't need anything. The Next.js compiler can compile also Relay. By the way, I am not your financial advisor, and get ready to see some strange things now, especially now, okay? For example, these prices. This is our crypto app. This is an app that we used to build in our workshops, where we run the backend in Hot Chocolate, in .NET, and the frontend in React, GraphQL, and Relay. And yes, we collected these real prices, but it was something like a bit more than 1 year ago, when Bitcoin was riding high. Today, probably we are at half of this price. And we will see a bit about that application. For example, we can do a lot of stuff. Some things are kind of normal for us, or we can imagine that, for example, querying for data, right? Or doing mutations, a way to modify the data. Or subscription, something like to get the prices continuously, right? And we are not doing a query with long pooling. But also we can do things like upload images or any other media. And that is sometimes something that is not so obvious immediately. Good. Let's try to see how we build some of this screen and how we use this ecosystem. This is one of the views. We call this view the dashboard. It is about a lot of currencies. We have really a lot of components here, right? We are focusing in the main area. And there we have lists. We have several lists of currencies. For example, this one we call it ticker and has these data requirements. We are talking about 10 currencies sorted by market cap and with real-time updates for the price. Here we have this carousel, are 3 currencies that are here pre-selected. We can see Cardano, Algorand, and Bitcoin there in that list. We will see later. And here we have another 2 lists that is called our spotlight, that contain the pre-selection of gainers and losers of the day, something like who was best or was performing today. Then let's see this application running. Here I have exactly that code that powers that application, and I have my Next.js server up and running. Then let's see the application. I just refreshed to get from the beginning with you. I will do it again. Good. There we are. This is the application. We have the ticker running there on top. We have the carousels, and we have this couple of lists here. And the interesting thing is that we were able to query all this information, all these lists, sorted in specific ways, filtered in specific ways, in just one request. We got all this information in just one call. And here I am showing the network panel. In the network panel, we can see 3 operations. Maybe I am lying here, because I said that we can do a request, but we can see 3 here. Bear with me, let's take a look. Here we have operations. These are subscriptions because we are asking for prices, updating the prices here. Here I have another one, is subscriptions, because I have here a small icon here that is receiving messages about notifications that happen in the application. For example, when the price goes up or down some value. But we have just one single query, and it's this one. This is the query that I did, and this all the data that we receive. Then we can see here the data. It's a bit difficult to understand it, but let's try to do better. I will do here right-click, and I will copy this as Carl. And now I will just double-click the link there, that is the URL, and immediately we are opening Banana K-Pop. Banana K-Pop is one of the products of our platform. I work a lot in that part because there is a lot of front-end in this thing. And it's our GraphQL IDE, but not only. Okay, we are integrating other services there, and we have more things than just an IDE. And now I will paste here the query that I copy in Carl. When I do that, I put that in memory the banana K-pop can detect it and automatically create all the information from what is in the clipboard. And if I execute it now, here we can see the same data that the application was receiving. Then we have a ticker here, you can see. I will collapse it. We have the featured. Featured is this carousel here, each of them. And also we have the losers and the gainers. Okay? And we receive all this information in a single call. But there is a lot more here. There is really a lot of work behind this thing. Let's see a bit about this query that is really what we send to the server. We ask to the server, we want exactly this data. And then here I have something like, okay, this is the data for the ticker, this is the data for the feature, and this is the data for the spotlight. And everything composes my query. But there is something like in JavaScript, right, like the split operator. Something similar in GraphQL. We are spreading these that are called fragments. Fragment is a concept in GraphQL that means the data contract between our component and the GraphQL API. And here you can see some of them. For example, this one is about the feature. And to create the feature, we need the symbol, the color, and the price information to create the chart. This is exactly what we need in this part. We need the symbol, we need the color, and the price information for the chart. Okay, and if I continue here, we will see that we compose this query. We have a lot of fragments again and again. Here, for example, we can see the spotlights when I have the gainers and the losers. Let's see this one even about the feature that I was mentioning before. Here we have the list, and here is where I am saying filter, Bitcoin, Cardano, and Algorand. That means that here we have all the information. We are saying exactly how we want to filter, how we want to sort the information. And this query is almost 100 lines long and was composed by the compiler, because really we never did this query so big like it is. And we will see how this is done. But also let's look here, because now we are in this screen. I will go a bit deeper later. Let's see here, we have a lot of information that Banana K-pop calculates when we do the query. And this is what was happening when we executed, when I click here, run. And the thing is like, I started the query, this is my operation, and here we received data. And I received first, and there is a patch here, I received the ticker and the feature. But I have not received the others, the gainers and the losers that are there for the spotlight. They were coming a bit later, in another subsequent answer from the server. And here we have the gainers. Then this is interesting because we did just one single request, but we received multiple patches. That means that with one HTTP connection, we were able to keep it open and receive multiple times information. And why we did this? Why this is interesting? If you, and here I saw that you know GraphQL, you know that before to do this thing, we were forced to split our query in different queries. We were forced to run 2 or 3 queries to do this thing. But in this case, I was able to do it everything in one. And why we do this of splitting the query? The point is like, here we have hundreds of fields, right? Don't know exactly how many, but there are a bunch, right? And the thing is like, these fields in the backend, in some cases, not in this one, could be just coming from a single table in a database. In that case, it's almost guaranteed that will come all together. But in this case, we have data, and a lot of them coming from multiple services, multiple microservices. And these microservices in general are networked services. Then, in this context, when we have multiple networked services, when some of the fields are provided by one service and another by another service, GraphQL could collect all the data and send it back, but that will be done just at the end, when it collects the last field. Then we will be forced to wait for the last one. That's why at that time, we were splitting the queries by hand. We know that from the front-end point of view, the user will have the focus point in this area, in the top left. And also, we want that our layout doesn't shake and so on, right? We could fill this screen with placeholders, a thing that I really don't like. And not even sometimes not even easier to do it because we don't know the size of the elements. And it still will produce some shakiness in the screen. Then, in the past, we were forced to do a query maybe for the ticker and the carousel in one call, and in a second call, make the gainers and the losers. Look in this simple screen that I did here, but could be a lot more complex. The losers are almost out of the viewport. Then the thing is like we don't want to wait to render the screen as much as the losers takes, right? We would like to render the screen as faster as we can get the ticker, for example. This part that is more important for us. And this is what I did here, okay? Using GraphQL, now we are able to do that just writing here differ, okay? And here I have my gainers and my losers, and the only thing that I need to do is say, look, this is low priority for me, you can send this later. And that is what the server is doing. The server could make it maybe, send everything, the information all together, or could define that it's better send the first part. The first part is guaranteed for sure that will come, but could say that, okay, the other could come together or could come in next patches. And this is what we see here. And look, one more thing that is a bit strange because sometimes it's not so easy to see this in the server, that the order of the patches is a little bit random, and that is the thing that happened with the networked services. Then, because the specification says that the part that is not different need to come first, here we got the ticker and the feature. That will come always first. As long as it takes to resolve the slowest field, will take this part. But what comes next? The gainers or the losers? In this case, we were not lucky. The losers were coming first. And this is a problem for our UI, because the losers are here, are in the bottom. If we are rendering in the order that the things arrive, we will be rendering the first parts, all good, and then when these are coming, and in this case the losers were coming, the loser will be rendering in this area. And when the gainers come, push down everything. Now, that is not a good user experience. And in this case, we are using some other things that we have in React to guarantee that the layout works as we expect, that we can render in the specific order that we want to render without breaking the layout. I will show you this in a bit. But now let's see how I did, or how did the compiler to make all this stuff for us. Because now I will show you how is the way that we work and how this big thing is composed. And it was never done by me, or at least directly. Good. This is a simple snippet for the first component that we have, for the ticker. Okay, this is the idea. Okay, here I have a container that is in the component, in the dashboard, in the root of the dashboard, where I collect all the data requirements that I have in the screen, in that view. And here I am showing just one of the components, the ticker. But what we do is split the others, as we saw in the big query. right? Then that's why this becomes so long later. And how we do this thing? We don't do like usually we could think about, say, okay, I need a list of 10 items, and then I collect the data and I do prop drilling and I pass the information top down to the children, right? We do exactly in the other way around. Let's go here. We will think in the other way around, not in the top down. We will go bottom up. We will go to our list item, this small component that we have here, each of them, and we will define what this component needs. And then we will compose these requirements into the parent, and then into the parent again and again until we arrive to the root of our query. Let's do that here. Okay. You can see, here I have the ticker where I need this information, the symbol, the color, and the price, just to make each of these in the ticker. And then I compose this information into the parent component, into the list. In the list, what I am saying is I need the first 10 items, and I need them sorted in this specific way. And here is where I split what I have in the children's. And then I do this again, I compose in the parent. Let's see this in the real code. I will go to this one, to the ticket item that is in this folder. In general, I follow this pattern. Each view is a folder. And I will go bottom up. I will go to our children, the ticker item, and we will see what we did there in the screen. You can see I have the information that I was requiring there. What I am using here is a fragment. This is a hook that comes from React Relay, and it's a similar hook to what we are using in React, and allow us to define what are the data requirements of this component. And in this component, in the fragment, what I say is exactly what I need here. And what I mean for that is like any field that is in this fragment, like the symbol, should be consumed inside the same component. It is like a bad practice, and probably it's wrong, if we find here defined some field that is not consuming directly in this component. Because if someone needs some property, that component should define it. And we should split it somewhere. Why we do this? Because we want to work in the React way. We want to think in isolation. We want to work in our component. In this way, when I see this code, I know that, like developer, I am creating this ticket item. And whatever I need is here. And if I don't need it anymore, if I don't need, I don't know, the color, I just need to remove it. And I am not breaking someone else. This data, this fragment is my contract, this contract between this component and the GraphQL API. And you can see even the convention. The name of the fragment follow the name pattern of the component and follow the name pattern of the file even. There is a combination and even enforced by the compiler to do that. Then, if we read also this component, we can see that once that we have the data, we just consume it. We can just use it. It is a bit strange, right? And we will see that more in the query, because it looks like this fragment is able to get the data, and we are able here to just use it. But we know that we are doing a network call, right? But the code, anyway, for us, looks pretty much synchronous. Looks like, okay, this works just. There is something surely strange here. We will return when we see now a bit more the query. Good. Then this is, for example, this component. Now, if I go to the parent, that is the ticker, there is where I define my list. We could call it this list, right? And you can see that here I define an alias, that is this ticker name that I put here, and I define exactly, I want the first 10 items, and I want them sorted in a specific way. In this case, I have hard-coded these values, but could be that we want to pass variables. This is also possible, and we will see that. In this specific case, I was just lazy, and I defined some fixed variables, right? But in other places, we are forced to have variables in a way that we can dynamically inject this information. Good. Then you can see in the list, I compose the fragment of the ticker item. In this view, in this list, I have these requirements. I need, by some reason, to have the ID and to have the symbol. Okay? Then the symbols, we will see later, is because here we are doing a subscription to get automatic updates in the pricing. Then I need to get this information to do that subscription. And the ID is because here we are doing a map, and usually when we map, we need to have a very good key, and usually these IDs that in GraphQL and in Relay are called global ID identificator are unique in the whole schema. It's more than a simple ID. It's a very, very strong ID. Good. Then I did my ticker item. I did the ticker that is a list. And now I go to the container that collects these requirements. And here I split my ticker item. Imagine like we do in JavaScript with the object of the arrays, and we split them to create others. And in this component, that is this container, I am just doing some simple layout. I am stacking there these components in the screen, and I am collecting the data requirements. This is a way of requiring data. This is another hook, use lazy load query. There are different ways to do that. If you are very advanced with these things, you probably know others. But this is easy to understand, and it's very good. I would say that probably Facebook arrived to 1 billion users using just this pattern. Then, if you are close to that, start to look the others. Then, what happened here? This is a hook that will fetch the data and will inject the data into my component. And as I said before, this looks pretty strange, pretty straightforward, because here I can get the data directly from the hook. But as we know, this will not happen, right? Because we know that at least most of the time, or at the beginning, we know that we need to do a network call. And this, what is happening here is that we are using the suspense API, and this assignment will not happen. We will throw here a promise, and when this promise is resolved, the component will re-render and we will have the data. There is a case where if we have the data and the data is already in our cache, then this will just render immediately. In the other cases, we will have some bunch of milliseconds of delay, right? But what is interesting for us is that, as you can see, almost there is nothing, no complexity around that. These components express exactly what needs, and it's a query of 100 lines long. We have a lot of information sorted in a specific way, and it's no more complex than this and what I was showing before with the ticket. If we see the other components, here we have the spotlight, for example, with the gainers and the losers. Again, the same. There is no real complexity, okay? The complexity is more or less always in the same level. We have a fragment, we define here what we need, and we spread our other fragments inside, again and again. It's a very simple pattern. Gainers and losers are one copy of the other, then imagine this one, but sorted in the other way around. Not so complex. The same for the others, and again and again. This is interesting. This we show in the workshop. We build this, all this stuff. and we go really deep into this detail and many other details. Okay, and the thing is like, how is possible that my query gets the data? Because for sure this hook, like this, out of the box, without any network information here, is pretty strange that can get data, right? Really, you know how it is. This hook is connected to some context provider, like we have our theme providers and others, and that is where we define our information. In this Next.js application, as you know here, we have our routing, and here you can see a bunch of providers just to put colors in the screen and so on. But here is where we have our relay provider. And this relay provider is who is in charge of make all the network communication. What we need to do is supply to relay a way to fetch or to do mutations or to do subscriptions. We call this a client, the relay client. And our client is written in this file. In general, you can start with something like 20 lines, and we do this in the workshop. We start very simple. But here we have a more standard version, something like 300-400 lines, with a lot of comments. I will say that 50% of these are comments just to show a lot of different things. You can see here, for example. And even this one is able to do subscriptions over WebSocket or over server-sent events, because we try to show all these possibilities. Then it's not so complex, but somehow you need to write this code. This is one of the things that at the beginning looks like make Relay a bit more difficult than other solutions, but also shows the flexibility that has. We can do whatever we want. We can define our network layer exactly as our server wants. That means that we have a lot of freedom there. We are not fixed in a vendor solution. And it's not so hard to do it. If you do our workshop, you go with the code out of the door. Good. Then I did here some trick to fake some lower network connection, and then we can try to rerun this component. And what I do is put a delay of 3 seconds, always. Every time that we get a patch, we have 3 seconds different. And this is showing like, that's why we can see now the spinners and so on, because else the server is too fast to see that, right? And you can see at the beginning we wait, we receive the first part for sure, and then comes the other part. Depending how lucky we are, could be that the gainers come first, and then we continue to wait for the losers, or could be that come in the other order, and then we have something there, also working with the suspense API to guarantee that the UI is always rendered in the same way. And this is something very nice there. Let's remove this one. I will show you one detail more. As long as I was typing there, and I will take one of these that we were doing, for example. We have a lot of developer tools around. Look here, the linter. Here, there is a plugin for VS Code provided by Facebook, by Relay team. And look what happens if I do a typo there, okay? This is very handy. If I mistype one of the fields, we can catch it immediately in the UI, right? And this is a nice thing for the developer experience. But if I do the same typo, and let's say I save it into my file, I can run here the compiler, and the compiler also detects that thing. Okay, and here we have some information. Like, okay, that's wrong, right? This happened, right? The compiler can run in different ways. Here I am running by hand just for the demo, but you can run it in watch mode, and every time that you say something is kicking there. And also here, if you have VS Code, you can just make it run directly from VS Code. And this is the power of the compiler. Now, there is a lot more there. Really, Let's see how we go with the time. I will need to speed up. The workshop was 2 days here, guys, Monday and Tuesday. Now I try to do it in 1 hour. Good. Look, what happened here? The compiler comes and replaces this code that we see here, this GraphQL tag, this that we call GraphQL tag, and contain this information, is really removed by the compiler. The compiler gets this thing, validate this thing, check that the fields are okay, check this against our schema. Our schema is here in one of these folders. And if everything is okay, then we'll compile that code. And when this compile this code, generates an artifact. The artifact looks something like this. It's a lot of information that is really what is bundled inside our application. It's not that long query that we saw, it's this thing. And this thing is optimized not for sending information for the server, that also it is, but mostly for when we receive the information from the server, how we normalize that data and how we can push to the store. Relay works with an store under the hood. In this network layer, we define a store. The store is similar to Redux. Our components are subscribed to that store. When we push data to the store, the component will render. It's a bit smarter than the normal Redux stuff, because we'll just render the component that has a subscription for some field, and that has changed. Okay? And you can see all of this was optimized at build time, because in general, our applications are built once and deployed many. And the artifact is static. Nobody will change it. Then we can do all this process to optimize the application to run faster at runtime. If we don't do this, if we don't do it at build time, then we will need to do it at runtime. And we will need to do it when the user is trying to execute the application. This has a lot of problems, especially if you have low-end devices. But also is that you break at runtime, and you don't want to do that. It's much cheaper to do it at build time. Then, or use Relay, or use whatever the other code chain solution you want to use, but try to compile at build time to guarantee that you don't break at runtime. Good. Then I will try to speed up because we will go very short on time. Good. Here I will show you how I did to, in the React part, to guarantee that the list is rendered in the order that we want. We are using there the suspend list. The suspend list with these parameters guarantee that the components are rendered in top down. It's rendered forwards. Okay. Here I have not in the suspense, my fallback is a false. That means that nothing is visible there. But we could put a spinner. We could put even 2 spinners, one for the gainers, one for the losers. That will create 2 spinners in the screen. Probably is what you want. You can choose that with this parameter here. Or you can use this one that I put here that is collapsed, and we'll just show the first of the spinners. And when this is rendered, then we'll pass to the next one and we'll show the next spinner. In place of having a lot of spinners, you will just show one at a time. There are more details there, like the dividers only appears in the moment that the gainers are there, and so on. Let's move fast. Here I have another screen. This is called a screener. In this screener, we can paginate our coins. We have hundreds of them, right? Then we want to paginate them. And here are the requirements that we have for this screen. We want to paginate 10 per screen. We want to have this load more button that we need to click 1 time to activate it. And then after that moment, we have infinite scroll. And we have here sorting. Here there is a combo box that we can sort. And here we have a search, and then we can search information there. The component was created in a similar way that I did before. But let's see first the component working. I will clean up here, and then we see the component working. Then the first thing is like, here we did one call for the query to get all the data that I need for this screen. The other is still my subscription for this thing on top. And now, if I click the button Load More, we are doing one more call. In that moment, every time that I arrive to the end of the page, the infinite scroll triggers, and we have another call and again and again. Okay, that is what is happening there. Relay has first-class support for cursor-based pagination. But also, we have this possibility. We can open here and change our sorting. I change the sort, and we got another call. If I change the sorting again, another call, and again and again. Okay, and now let's see this. If I go back to one of the previous sorting, I have not another call. The same happens if I go to another of the previous sorting that we did before. This is because we have this information already in the store. There are several parameters, several options that we can put in our hook to say if we want to do this or not. But in general, we can say something like this. Use information from the store, otherwise go to the network, or use information from the store, but anyway, go to the network, and if it's necessary, refresh my component, and so on, right? This is very handy, especially when we have something like the user click one link, navigates to the next page to discover that was a wrong link and need to go back. Okay, in that case, we are not going against to the server, and this produces a lot less overload in our server, apart from a much smoother UI. And look here what happened. We can see the same with the search. This is a simple text search. I will type one character at a time, and you can see every time that I am searching for Cardano, that is one of the cryptocurrencies, and you can see every time that I do a keystroke, we refine the search and we make another call to the server. But if I remove that keystrokes, we get back the list without going to the server. As I say, this is by configuration. If we want to go into the details, there are two things here. Let's try to speed up because I am pretty sure that I will have problems. The main thing for you is this thing. We have another kind of fragment, and we have three kinds of fragments, three kinds of hooks in the React Relay. This is called use pagination fragment. Has a bunch of configurations here where we define how we want to get the information. But this is the information that the Relay compilers need to make this pagination happen. The hook has all these handy flags and methods that allow us to paginate in both directions. In this case, I am showing just forward. Then I have something like has next, or load next, or is loading next. But we have the same going backward and with the previous and so on. For what we use this one, for example, look this. The load next is what I use in the on click of the button. Every time that I do the click, or the button, the text that is in the screen after the first activation will trigger this load next. I did not say anything else. I just say load next, and Relay knows how to get the next page from the server. And with the other flag, like for example the is loading next, I use it to show a spinner or to disable the button. There are a lot of these very handy flags that are the typical use case for us. And we have here also this refetch. In general, any pagination fragment is also refetchable, and this refetchable is what allows us to refetch the information when we change the sorting or we are doing this filtering with the keystrokes. Then what we do here is like compose the variables that we want to send to the server and say, okay, now sorting this way or filtering this way. And what we say is like refetch. Okay. There is something interesting here from the React point of view. Let's see this. Look what happened when I will refresh and I will type Cardano again. I will go slowly you can see what happened, right? The server is fast, everything is there, and so on, right? Now, it's not easy to see. Let's try to change our environment and make it slow, right? Then, goes again. Now I do Cardano again. Now you can see I blurry here the screen, and then the data is coming. And now we force a 3-second delay, and we can see this effect. But also there is some trick here from the React point of view. That is this one here. And do you know this hook, use transition in React? Okay, this is one of the cases that you can use it. Look, I will disable that line, and I will run again the same. Let's run from scratch. This creates a slightly different user experience. Look what happens when I do C. My screen is gone. Okay. Okay, it's an edge case. We can do maybe a bit better. Maybe put the text, the search field and so on outside. But anyway, the list will be disappearing. Then with the start transition, what we are able to do is say, if this component, if this method will suspend, we will keep showing the data as long as this happens, in place of removing that from the screen. And you can see that it's really a much better user experience to do that than this one that is a big spinner in the screen, right? It's much simpler to see that the user can see their data and then the data change slowly, right? Then this is a very good use case for use transition if you were not using it. We use the VC, for example, that comes also from the React hook to show this blurry effect in the screen, or you can do a spinner or whatever you want to do there. Good. Let's try to move. Here we have more, and let's try to speed up. This is a view where we can see one of the currencies. In general, in the application, every time that we click a currency, we can see information of this currency. The components are done like we saw the first one. It's just composition. We have a lot of them here, are all composed into the parent again and again. But here in the top, we have two things. We have mutations. Mutations is something to produce a side effect in the server. In place of getting data, we are modifying data. And the other that is more clear is that we have the subscription for the price. We want to get prices. With Relay, you can use long pooling also. There is a flag there. You put in your query, you do long pooling, but you don't want to do that. That is also overhead for our server. You want to be notified when this happens. And then we use subscriptions over WebSocket or over server-send events, or whatever you want to use. It's up to you to write the network layer. Then these things that are quite complex, at the end are much simpler than what we imagine. Okay. I will show you here how we do the mutation. The mutation is a hook that is called use mutation again. It's not so difficult. The keyword here is mutation, and the mutation is something that allows to modify data in the server, but also to query about the changes that produce this mutation. It's like we produce a change and we get back information immediately. And this is what we can see. It's like a mixed modify and query in one way, in just one shot. And it's very simple. Here I have created my custom hook around the use mutation. And for example, this one I use it to add the currency to the watch list or remove the currency from the watch list. And what we do is send to the server the mutation, say, okay, this currency, this symbol, this Bitcoin, put it into my watch list or remove it from the watch list. Let's see that. If I am here, for example, in Bitcoin, and I click the icon here, we can see that now it's in my watch list, or now it's not in my watch list. And this is the watch list. And here we get the information of the currency that I was adding. Also, this list is paginated and all the stuff that we saw. This one has subscriptions and also has the mutations. Then you can see in this case, doing mutation is quite simple. There is here a small detail, and this is called optimistic updater. This is very nice for mutations, so trivial like this, like a like button. We produce the effect in the store that will produce information that comes from the server. Like we fake the value that will come from the server. When the operation is executed and we get back the information, this temporary value is rolled back, and the value, the real value coming from the server, is merged into the store again. In theory, it's not producing difference because we will get the same value, right? This is something handy for a like button, but don't do this if you are transferring money. Imagine you are sending $1 million there. Maybe arrives, maybe not. It's not like a good idea. Yeah. Okay, let's move on. Here I have the other, and with this one we are finishing. This is a subscription. How we get information for the coins, right? We have any of these is getting continuous updates. Our server produce in the way that we did this, produce a change every minute. At least a change will happen, right? If we keep looking here, we can see that prices are changing. And this is the subscription. The subscription is almost like a query, okay? Just with the keyword subscription. And that is all what we need to send to the server a subscription. Here, this is called the configuration. It's a bit strange, but it's similar to the others. It's also the only hook that we have to do subscriptions. And here we have a dependency array. As long as this dependency is not changing, then the subscription is running. In the moment that the dependencies change, we invalidate, like use callback, use memo, whatever other hook. The subscription that was on the fly stops, and we start a new one. And this is what happened here. Every time that I click these buttons, we can see we stop one subscription and we start a new one. This is happening continuously there. Then I hope that you got some information about this, about what is Relay, how to work with this, and how to work with GraphQL, because the GraphQL ecosystem is becoming every time more important. We give support to very big companies. We have signed a lot of NDAs, but if I say to you Microsoft, you can imagine what it means. And a lot of other companies here in Norway, we have been several times helping one of the companies that is close to the 100 in the Fortune 500. Then many companies are moving into GraphQL really strongly. We believe that this ecosystem, React, Relay, and GraphQL, each of them is very important, but all combined makes a product really, really powerful and that can scale. This allows us to scale not only in the speed of the performance of the screen, also in the teams, how many teams we can work together, because each one of them is working in part of the application in one component without affecting the others. The tooling helps us in this work. If you are using GraphQL, if you don't know Relay, just give it a try. Just give it a try. Test it. You will discover that it's something you will not regret. If you want to learn more about this, you can join our workshops. We are doing this continuously in the NDC conferences. Last year we have been going around the world. And now the next one we will do after Oslo is Copenhagen. We will be there. And we also are running one online workshop for the European time. The last one that we did for American time and was sold out immediately. Then if you are interested, you can do this. It's 2 days workshop, 8 hours per day. And we create .NET backend in hot chocolate, frontend in React Relay, GraphQL as I was showing, and we go in details, and you go out of the workshop with materials. with an example, with an application working. It's not something trivial. Good, that's it, that's all. Thank you very much for your attention.